Hello and welcome to Program with Sam, and this is Java Lesson 5. So today we're going to be looking at enumerators and interfaces. So we'll start with enumerators. Now enumerators are a special type of Java class, and they're used to define a group of constants within your applications. Now in addition to holding constants, enums can also contain methods, and these can be useful for then testing or just using your enumerator effectively in your applications. So let's make an enumerator to begin with. In IntelliJ, we can just make a Java class, but we can select enum. And if we call it difficulty, what we can do is we can then define the difficulty steps as easy, medium, hard. And those define the difficulty steps. Then if we want to do public string to string, we can override the function to return the super of the string. But in this case, what I want to do instead is switch. So you can see here, using a conditional control statement that we've seen before, how you can use the enumerators to represent different constants. So in this instance, we're overriding the default to string function in enumerators, which will essentially just return a string of the constant name. But we've defined three enumerators such as easy, medium, and hard. And those could be used to then control the application's behavior in different ways because they're constants. So you could have a setting called difficulty, and it can take a value of easy, medium, or hard. And then depending on that value, which you can control with conditional statements and check with conditional statements, you would then change the behavior of the application accordingly. Now, another way in which you can use enumerators like this is, for instance, what if we did direction? And we had up, down, left, right. So what we could do in this case is switch it to up, right, down, left. And so that will move it around in, it'll go up, then right, then down, then left. So it'll move back into its original position. If we declare a function such as public void next direction. So in order to do that, we can do something akin to this. We can say return vals. Oh yeah, we'd have to declare a list of some sorts first. So let's do private static directions. Yeah, and in that case, yeah, we'll do directions, but it needs to be specified direction array directions is equal to values. So that will get the values of this enumerator and populate an array with it. So then we say directions, and we'll say this dot ordinal +1. So it'll get the position of wherever the current direction is, this dot ordinal, +1 to it. So just move along. %length. Now what that is going to ensure is that it's not going to go out of bounds, essentially. So that will mean that if, for instance, you're on left, it's no longer going to +1 and go out of the bounds of the array. It will then wrap back around to up. And so if we then write a simple main function, I is less than, let's do 20 iterations, I++. Let's also declare a direction. So direction d is equal to direction dot up, d dot next direction, system dot out dot println d dot string. Then if we just make a quick run configuration for that, and we'll call it run enum, selecting that as the main class. We should then see in the terminal when it's finished building Ooh, it's not changed direction at all because we haven't assigned it. There we go. So it's gone from up, it's gone right down, left, up, right, down, left, up, right, down, left, and it keeps switching direction to the next one in the list. So that's another idea of how you could use it to how you could use enums in your application. For instance, let's say you had cars moving on a road and you needed to determine which direction they were going to be moving next, or whether they were going to take a random direction. You could use an enum to define the directions and then just have them pick a random direction from that enum. Because they are technically a collection, they do have a special way of iterating over them. They do have their own special collection, which I believe is called enum set. And that's basically just a more efficient way of handling them when you're iterating over them. But in terms of enums, for now, that is going to cover it. So the next thing we're going to be looking at are interfaces. Now, interfaces are a very special type of class. They're quite similar to abstract classes in the sense that they allow you to provide some form of abstraction to the user, some form of abstraction to your application. But interfaces are actually purely abstract. So whereas in the abstract classes, we could define functions and we could define a constructor, although we couldn't instantiate an object of the abstract class, we could define an instructor for it, a constructor that would then set up the object, so to speak, set up the variables within it. Interfaces do not allow you to do that at all. So one of the things that you can do is you can say int my integer. Everything is static by default. So if you're declaring something in your interface, you have to make sure that it's assigned a value because it's static and you don't have a constructor to initialize it anyway. This holds true for objects as well, I believe. So let's try an array list of double and call it list. It needs to be instantiated. So whatever variables you're having in your interface, they're going to be static and I believe final by default. So that's another important thing to bear in mind when you're making interfaces, is that whatever variables and objects that you're declaring in it are going to be static and final. Similarly with functions, if we were to go public void set name and take a string name, we can't actually define a body for that function. All we can do is that. And then you'll notice here it's grayed out public because it's redundant. Because everything in the interface is going to be public. Correction, Sam, as it turns out, you can create bodies for functions, but only for private functions when you're making functions in your interface. This is because it was an update in Java 9, and it just means that there's even less code reuse. So obviously, interfaces may seem like they are very similar to abstract classes, but they seem almost, limited in a sense that, all your variables have to be static. Your private functions are purely for this class, purely for the interface, and and all of the public functions are by default abstract. Well, interfaces are exceptionally good for grouping together similar functions in your application. So if you have sort of functions that are very similar in nature, you can group them together in an interface, and that way you can then implement the interface in other classes and define their bodies there. So for instance, if you have, say, a neural network, and you are working with neurons, for instance, and you have your neurons, every neuron has an activation function. You could use an interface for the activation function because it's just a given function that every neuron needs to have. So then neuron could have an activation function, like the interface, just the abstract interface. And in that object, you could then store maybe a sigmoidal activation function, which just implements that interface. So in this instance, if we had public, we don't have to worry about that. We could have double activation function. So that just declares that it's an activation function that will need to be implemented by whatever inherits from it. So if we now create a Java class and we call it sigmoidal, we could then have implements my interface. When you do that, as opposed to extend with an abstract class, what's going to happen is it's going to throw up this error. And in that case, you're just going to implement the methods, click OK, and it's going to implement the methods that are defined in here that you then need to define in your new class. So for the purposes of this, we've demonstrated it. We're not going to implement a sigmoidal activation function, but you get the idea. For instance, if you had something like maybe different formulae that you wanted to execute, you could have an interface called formula and a function in it called run formula. Then in any inherited formulae that you make, all you have to do is define the formula that's being run. And that way you could then make, in theory, any number of formulae that can be run just by calling the run formula function from the interface. It's quite an efficient way of implementing grouped together functions. So why would we use interfaces over abstract classes? Well, one of the main reasons is that interfaces are probably better for you in terms of uses with reflection. So when it comes to creating backends for users to then create their own classes that run in your application, interfaces tend to be very good because you have to enforce the inclusion of methods in their class that inherits or implements the interface. Now, in an abstract class, you can do this as well by ensuring that the function is abstract with no declared body, and they'll have to do it as well. But with an interface, you can then leave the door open for them to be more flexible with the variables that they want to use and store, while still ensuring that whatever function is called in your application, they will have a function for it in theirs. That's it for this time. Next time we'll be looking at serialization of classes, serialization of class hierarchies, and then saving and loading those objects using the serializable class in Java. If you'd like to follow me at ProgramSamBlog or follow the blog directly at programwithsam.co.blog, that would be much appreciated. And I'll see you in the next one.